Dear participants, welcome to 50th International Congress on Human-Computer Interaction Optimization and Robotic Applications. The symposium is organized by Tokat Gazi Osman Pasha University from Turkey and National Technical University Kharkiv Polytechnic Institute from Ukraine. The symposium is technically sponsored by IEEE's Turkey section. Thank you for your scientific contribution and support to the symposium. Now let's start the session. If you are ready. First paper belong to dear Ümit İlhan. Okay. Dear Van Lee, are you ready to present?
Yes, I'm here.
Okay,
I'm here.
So I present the paper.
Okay.
Okay, thank you so much. So I will let
Dear
me-
Van Lee, you can start your presentation.
Okay, thank you so much. I will start it now and
Okay.
let me share my screen. Okay, so let me start with a video. Oh, let me share my screen now. Okay, so this is the video.
You can share your screen.
Yes, I can share my screen now, and
You have 10 minutes, please.
oh, okay, yes, understand. So yeah, of course. Okay, very good. So let me share my screen now. So can you see my screen now?
Yes.
Okay, very good. Yes, and this is the video. So okay.
In this paper, we
here's something.
propose compare the size, automatic synthesis of size comparison animations in virtual reality. Given a group of assets in Unity Editor, for each 3D shape in the group, we attached a box collider component. Then, we sort the 3D shapes according to their heights and place them along a parametric curve. Next, we calculate a path for the camera to navigate along that parametric curve. In the end, users can watch the size comparison animation using Steam VR. This video shows a size comparison animation synthesized for 55 virtual tree models whose parametric equation is a line function. This video shows a size comparison animation synthesized for 76 virtual stone models whose parametric equation is a sine function. This video shows a size comparison animation synthesized for 48 virtual city scene objects whose parametric equation is a spiral curve function. This video shows the experiment result of a preliminary user study that tests the user's experience in watching our synthesized size comparison animations in VR. This is the end of the video. Thanks for watching.
Okay. so let me present the paper now. So I'm presenting the paper, compile the sites, automatic synthesis of sets. So basically, so this shows the overview of the approach, and so given up to amount of the model, so basically I will compile the size according to the height in ascending order, so that given this comparison, and then automatically generate this comparison animation in the virtual reality. And this is exactly the left figure exactly is the result that has been so the left part is a generated result and right part is the user study. And basically so here is overview of the approach. And basically given the input of the 3D shape and as a group. And then so for each 3D shape, we calculate the box collider according to the height, and we do the insert shot. After the insert shot, there will be sorted 3D shapes, and then we play that shapes along a curve. And basically, this is curve is defined through a parametric equation. And then according to this parametric equation, we will calculate the camera path according to this equation, and also according to the height of the objects. And then in the end, we generate automatically generated the set comparison animations. So in these implementations, we have done this on the Unity editor. So therefore, the user can see these animations in VR. So this is exactly how we has done for this project, that it can automatically generate the set comparison animation in VR. So here is the experiment results. So basically, so this is the first experiment result that have generated the animation for the long linear function, and this linear function and is online. All of these models are tree models, and for this one is the second one is the sine function, and all of these two models are played on the sine function, and here is the third result. That is a scene object, so you can see the buildings and maybe cars, and you can see this is some buildings and maybe some bars and vehicles, and these are scene objects we can see every day. And this is another comparison animation generated along this spiral curve, and spiral curve is defined as this function ft, and this is exactly the result that is automatic synthesized. So in the end, we have this animation. And as I showed you this video before, and there's a user study, and we also see that video. So this is my presentation. Thanks for watching.
Thank you for your presentation. Dear participant, do you have any question about the paper?
Yes, I have a question.
Okay.
How did you set the field of view settings of the HMD device? Did these settings affect the working results?
Yeah. So because so these models are automatically, so basically is in the eyesight and load the eyesight to the Unity 3D game engine, and then I implement the algorithm here, and it can automatically add the colliders and sort this object according to the height, and then place them on the equation. And for the detail of how it is placed, there are mathematical equation and calculations. Please refer to the paper for more details about how to align these objects on the curve. Basically, to simply explain, it's there is a node function, and according to this node function, and then it's using a Hermite curve interpolation, and then according to this Hermite curve interpolation, you can place object there automatically. And then next step is to place the camera along this curve.
Okay, I get it. Thank you. Which game engine did you use?
Oh, sorry, could you repeat?
Which game engine did you use? Unity or Unreal Engine?
It's Unity. Unity added in 2019.
Okay, thank you.
2019.
Thank you for us.
Thank you.
Okay, another question. Department, do you have any question? Okay, no question. Thank you, dear Wan Lee.
Thank you so much.
I wish you success in your career. Thank you again. Dear Ümit İlhan. Dear Ümit İlhan. Are you online? Dear Yaşar Daşdemir.
Yes, I can start
Okay.
my
Okay.
presentation.
If you are ready, you can start your presentation. You have 10 minutes, please.
Okay. Yes, hello everyone. Please let me introduce myself to you. My name is Yaşar Daşdemir. I'm a faculty member at Erzurum Technical University. My interests include database management systems, electroencephalography, signal processing, and augmented reality and virtual reality game development. We are conducting multimodal studies on virtual reality and electroencephalography. We think that these issues are important in the digitalization process. That's why we want to focus on these issues and find solutions to potential problems that arise from them. I would like to start my presentation under the following headings in this context. Firstly, I will introduce the subject and the metaverse, virtual reality, locomotion, and cybersecurity subtitles. I will then present the methodology, results, and discussions. Yes, metaverse is a universal and immersive virtual world presented in extended reality, mixed reality, virtual reality, and augmented reality. The domains where metaverse is popularity serviced are simulations, games, marketing, education, social interactive, and some of office applications. VR applications are a great example of how environments with immersive technologies such as metaverse can take our perception to a new level. More and more companies are using virtual reality for educational purposes. For example, because it is cheaper, more time saving, or less dangerous. A few industries that metaverse has impacted include automotive, art, education, factories, sports, tourism, defense, medicine, like this. The key components of metaverse are AR, VR, MR, and extended reality technologies. We all follow the advances in these technologies closely. In this study, we tried to find the problems and solutions arising from the use of virtual reality. We used a 6 degree of freedom HTC device in our study. We specifically choose this device with the 60 degree of freedom support to add even more immersion. Also, Microsoft's HoloLens 2 and Apple's Vision Pro devices are current developments to offer mixed reality technology. Yes, VR locomotion is a method of moving people within virtual worlds. Most VR locomotion methods rely on using a controller or walking in a limited physical space. This situation hinders the user's desire to travel in unlimited virtual space. Treadmills are designed to offer safe and close physical movements. Treadmills provide limited repositioning, walking to running, falling to standing. So some people find treadmills boring after a while. VR treadmills can also occupy much space. Like this physical locomotion using CAT VR treadmill, and a participant use HMD for artificial locomotion. Their artificial locomotion caused many cyber sickness situation. For example, nausea, dizziness, or disorientation, like this. Yes, cyber sickness movement in the virtual reality environment causes some discomfort on users. For instance, cyber sickness. Although such technologies provide a high sense of immersion, they can also trigger symptoms of discomfort. This condition is called cyber sickness and is very popular in recent virtual reality broadcast. And user experience is a sub-discipline of human-computer interaction that has received much attention from researchers. In recent years, educational games using virtual reality have been extensively discussed among the education and computer science researchers, especially on usability, cyber sickness, and user experience. The experiment was conducted with 45 volunteer participants, 32 males and 13 females. Average 25.44. 4 locomotions were used in this study. 2 of them were physical and 2 were artificial locomotion. In the figure A and B are physical locomotion, C and D are artificial locomotion. Questionnaires and evaluation methods are explicit. The commonly used questionnaire in experiments measuring cyber sickness is the Simulator Sickness Questionnaire, SSQ. The SSQ consists of 16 items on a 4-point Likert scale. Subjects rated each item on a scale of 0, none, 1 slight, 2 moderate, and 3 severe. Usability result, John Brock developed by the System Usability Scale, SUS. It is used to evaluate various products and services such as hardware, software, and websites in terms of usefulness. In this study, locomotion systems were assessed. Virtual reality immersion questionnaire. This questionnaire, which consists of 3 main sections, was used to analyze the engagement, engrossment, and immersion levels of locomotion techniques. Yes, when SSQ scores were examined, the lowest CS values were obtained with teleporting. Continuous touch resulted in the highest CS values. Like this, especially disorientation is very high in continuous touch. Its level is 58.77. When the system usability scores were examined, the most appropriate use was locomotion teleport. Omnidirectional walking has emerged as a difficult to use and low scoring locomotion. Statistically significant differences were found between physical and artificial locomotion. All Kaiser-Meyer-Olkin measures values were calculated in the immersion model level analysis. The sample size was used suitable for factor analysis. 0.50 of the values above are considered sufficient. In addition, the values in the Bartlett test result were significant. For example, p-value less than 0.01. Yes, as a result of exploratory factor analysis determined that the total immersion level consisting of 12 items consisted of three-factor structure for omnidirectional walking. And these three factors explained 79.65% of the total variance. Similarly, it was determined that the total immersion level for teleport consists of a three-factor structure. And these three factors explained 74.44% of the total variance. Yes, for UX, user experience designs, motion techniques encompass usability and experience during system use. Therefore, it is important to determine the variables suitable for cyber sickness in evaluating user movement experience in virtual reality supported application. Real walking from physical locomotion and teleporting from artifacts, artificial caused the least cyber sickness. Regarding availability, teleporting had the highest and omni-walking locomotion had the lowest. The virtual reality immersion questionnaire has been shown to have satisfactory reliability and validity in assessing the level immersion. Yes, thank you for listening. If you you want to more information about these topics, you can visit this link eegdatasets.erzurum.edu.tr. Thank you for your listening.
Thanks for your presentation. Dear participant, do you have any question about this study? Okay, no question. Thank you again. I wish you success in your career, dear Yaşar Daşdemir.
Thanks.
Dear Ashraf, Mustafa, Kadim, Bahya.
Yes, I'm here.
Okay. If you are ready, you can start your presentation. You have 10 minutes.
Okay, thank you. Can you see now?
Yes.
Welcome everyone, and thank you to accept me here. I'm starting about efficient routing in managed ad hoc networks using meta-heuristic optimization algorithm. Well, as a background introduction, in the recent years, we see a major shift in the information society, driven by commercialization and emergence expensive and widely available communication device like telephone and laptops. This evaluation of fixed mobile networks nowadays and the exchange of information in any time has generated need for more mobility and widely used in the network without infrastructure. So an ad hoc managed network is a collection of mobile entities that areas the need interconnected by wireless technology, forming a temporary network without infrastructure. No need to infrastructure to initiate this type of network. The immense interest of the research community in these networks is justified by glorious future and success, and in favorable needs like military field and natural disaster and health, something like that, that widely used. So as we can hear, this is the general schema of ad hoc networks, and starting with a GIS server and database and mobile data, and connected between the hosts from mobile, sending data from mobile from a host to another, like computer. So the motivation, current application is artificial intelligence aid development of algorithm, whose techniques are inspired of this social instinct and other animal societies. Starting with the swarm intelligence, is a subfield of artificial intelligence that integrate models inspired by nature, such as well-known colony optimization model and ant colony, which are strategy based on how ants search for food. Other models include artificial bee colony, which mimes the foraging behavior of the beehive, and meta-heuristic optimization algorithms that are based on the techniques employed by insects such as fireflies, bats, cuckoo-birds. Both of these realistic models represent foraging behavior of the beehive. The researchers are attempting to develop algorithms that can solve a variety of difficulties, like fungi have recently been employed as a model for the development. As we know that fungi is the best choice for the artificial colony, bringing data or food and also sending from one to another, and mostly owing the fact that the fungi are better locating food source and improving nutrition delivery networks. So problem statement. The major problem of ad hoc network is routing. This consists of ensuring strategy that guarantees at any time the connection between any pair of nodes belonging to the network and how to determine valid routes. If a break happens with one path, how to determine another path. Despite these difficulties, a large number of routing protocols are developed that can be classified into three categories: proactive, reactive, and hybrid protocols that gather between them. A routing protocol is responsible for task building and maintaining path between the source and the destination, while optimizing network performance. This task is particularly complicated in managed because of their particular characteristics. As a result, traditional routing protocol designed with the assumption of a fixed topology and a suitable communication medium. The contribution, the general objective of this proposed routing protocol for managed network based on this behavior on fungal colonies test in different scenarios and situations, as well compare performance with computing protocols. The protocol aims to operate with sufficient functionality and performance for network to provide quality service for route traffic scenarios due to the frequent topology change and due to mobility of the nodes, like moving from place to another one, and how to keep the network working with those nodes are moving from time to time or moving from place to place. In this new approach, we sought to discover which information within the universe of fungi could be useful to compose a new protocol for networks. The new trend search mechanism is construction of hive and mass flow of the fungal colony, inspired design of working model of protocol operation. The definition of wireless networks is a network in which various participating elements, laptop, mobile, and etc., are not connecting physically. Data transmission is done via Hertzian waves like radio and infrared. Allow user to move within the coverage parameter that can range from around 10 meters to a few kilometers. We have a comparison between the network without infrastructure, which means the ad hoc, and the network with infrastructure. We see the communication cell, intercell routing, and intracell routing and intercell routing. For the network with infrastructure must be an access point. For the ad hoc, it can be by the neighbor, any node's neighbor to the sending. And with the infrastructure fixed, managed by the base station, self-configurable, depends on the position of mobile terminals. It must be via an access point for the intracell routing, by neighbor for intracell and ad hoc, and intercell routing. It must be multiple access point, require only relay station. So the ad hoc network sometimes operate ad managed. We can call it ad managed. It's temporarily wireless network that does not require any infrastructure, and following alternative definition, it's an ad hoc. A mobile ad hoc network does not require any pre-existing permanent infrastructure to function because it's arises naturally from collection of mobile entities that are able to connect with one another. And as we can see, the ad hoc network, it's for example like this, from mobile to another, to the neighbors, can connect and send requests from one to another. Routing difficulty in ad hoc networks. In order to overcome the problem due to the different movement of mobile nodes, which may modify the traffic, an ad hoc network must therefore be able to schedule itself automatically in such a way as to be deployable quickly and to be able to accommodate propagation condition. In this case, where the destination node is within the range of the sender node, we will not need the actual routing. Unfortunately, this is not always the case. In fact, the node therefore will be likely to play a role of forwarding the bucket to its final destination. This leads us to say that it's possible that several nodes can participate in this routing. Proposed routing algorithm. It's for the proposed routing algorithm protocol for mind inspired by fungal colonies, behavior based on fungi algorithm. This proposed routing algorithm aims to solve routing and management problems in dynamic networks whose mobility and topology variation challenge the guarantee of performance of data traffic for various applications. Similar to bio-inspired protocols present in the literature, for example, the ACO, the ABC, among the other proposed routing algorithm, represent a communication model operate an ad hoc network on the TCP over IP architecture with a set of communication protocols and the new particulars. As we can see in the first image, this is the fungi monet. It's choose for the shortest path from G to E to A to D and to the final destination I. First, take the possible path and then it's analyzed which one is the fastest path and the shortest one to the destination from start to destination. Route discovery mechanism. The route discovery mechanism proposed routing algorithm is reactive. The source nodes start the discovery process when it has data to send and no route available to destination. This can happen if destination was previously unknown. The source node is, or if a valid route to destination expires or marked invalid. In this process, the source sends control packet of the route request type of request and broadcast through the network until it finds destination. When found, destination sets control packet of the route confirmation type replay to the source in the unicast to confirm at least one functional route between the source and the destination endpoint. During discovery procedure, once the routes have been established, it may happen that some are used more than others. So as they are more attractive to selection process. In this way, only routes that receive data traffic are updated and remain active. The other, after a period of time, are automatically deleted by a periodic recycling mechanism that detect inactive routes. So construction of routes between origin and destination. In this route discovery process, the construction around the trip path between origin and destination occurs. During this process, the control message gives the respective sequence number stored in the route table that represent a route signature link to an origin destination pair, identifying each search procedure as unique. This feature makes it possible to track the compare sequence number in different search. And for the route selection mechanism, the route selection mechanism is important for routing data and has function to selecting the route from destination using updated attractive information to routing table. The attractive like ROGE is local information for node I shared by all nodes in the neighbors. And in this sense, in any cluster of nodes, the expectation is that each node I see the information GJ in its route table, referring to any node J in its neighborhood. As we can see here, starting from the source number 2 to destination 5, it will take the path from 4 and directly to 5. After the break is happening, it will ask for the replay request, then the replay coming back from destination 5, and it will take another path after this path. It is a break. It will take from 2 to 4 to 7 to 6 to 5. A conclusion. It's aimed to propose, test, and compare new algorithm in managed inspired by fungal networks from biographic research in the biological area. It will possible to obtain academic view to the existential domain of these living beings and correct interpretation and of the mathematical models that represent their behavior in the search of several and for survival, and from there to launch ideas proposed in bio-inspired protocol. In proposed routing algorithm, the route selection criterion based on attractiveness of function of two factors, one specific to the fungal approach, a mobile biomass, and one that can be free chosen by the designer. In the present work, the available buffer space was chosen represented by the ABS variable. However, other quality indicator can be also considered, for example, the battery level, the radio signal level, among others. For future works, for this work, introduce optimization mechanism to reduce delay and overhead, for example, reduce the amount of the acknowledgement message. Which currently is directly proportional to traffic and directly impacts protocol performance, especially in high traffic scenarios. In this case, the acknowledgement message could be controlled by a timer on the active routes along with the data packet delivery. It will be more better of sending acknowledge message first than waiting to send the packet after that. Improve performance of the TCP traffic. One proposal is introduce mechanism to route acknowledge TCP message to return along the same path as the data packet, and insertion of control agents to update routes and reduce dependence on the acknowledge return message. Simulate and analyze other scenarios of different size, number of nodes and sources and types of traffic, like bursty traffic. Thank you very much for listening, and hope you have a nice day. Any question? I'm ready for it.
Okay, thank you for your presentation. Dear Pasim, do you have any question? Okay, no question. Thank you again.
Thank you very much.
Dear Isra Salman Atya, are you ready to present? Dear Isra Salman Atya. Dear Harun Boud Jellal.
Hello, Doctor. Yes, I'm ready if you want.
Okay, if you are ready, you can start your presentation.
Okay, thank you. Can you see my screen?
Yes.
Thank you. So my name
You
is
have 10 minutes, okay?
Okay. So my name is Harun Bujilal. I'm a student in Aydın University, master's degree. Today I will speak about NER-induced interactive display with OpenLection. In recent years, tactile display becomes an effective tool for communicating with users. This type of display goes beyond what traditional displays can provide, including other senses such as taste, smell, hearing, and sight, in addition to touch. Tactile displays are developed using haptic technology. Haptic technology allows users to explore digital spaces in the same way they would explore physical objects. The effect now, I will speak about the effect of the sense of touch and smell on the virtual world. The sense of touch and smell can have a profound effect on the virtual world. The sensation of touch can be recreated to make virtual environments more realistic and immersive, ensuring that users have a more engaging experience. For example, haptic device can be used to provide tactile feedback for virtual objects that can be felt when interacted with. This can create a more informative and interactive experience for users as they explore virtual world. Now, as you see here, this is my machine that I have done. I will speak about, give information about tactile feedback. So tactile feedback, also known as haptic feedback, is a form of communication that involves the sense of touch. It's achieved through vibration, force, or motion that are provided when a users interact with digital device. It enhances digital experience by providing physical feedback that references digital interaction. This can prevent users from getting lost in a digital environment, make them more aware of their usage patterns, and improve users' satisfaction. Example for tangible feedback include the vibration of a device when a button is pressed, the resistance of scroll wear, and the tactile pressure of a physical keyboard pressure. Now, thermal feedback. Thermal feedback refers to the use of temperature-related sensation or cue of provide information or enhance the user's experience in various applications. It involves the generation of heat or cold stimuli to create a tactile sensation that can be perceived the user. Now, this is as you see in the picture, we have sense of temperature. Temperature can be an important considered in the design of haptic device and application, as it can significantly affect the user's haptic experience. For example, a warm surface may feel more pleasant to touch than cold surface, and a sudden change in temperature can be during or unpleasant. Several researchers have attempted to include thermal feedback into tactile haptic devices that thermoelectric devices have been utilized to create warmth and coldness. The slow response time and power consumption are the two major problems of developed device using unconnected technology to develop temperature feeding at all. Developed cooling sensation using vortex technology. Another application, ultrasound traducers were employed to transfer the cold air to localized spot or the user's skin. Now, a sense of smell or affliction. It's, as you see here in my picture, I smell perfume. It's possible to integrate the sense of smell into tactile display in order to increase realism and enhance the overall user's experience. The sense is closely linked to the sense test and can have a strong impact on our perception of the world around us. By adding the sense of smell to tactile display, it might possible to create more immersive and realistic virtual environment or experience. So, sense of smell of sense can also enhance users' experience virtual world, as you see here. Now I will speak about sense of surface property. As you see my finger here, it's my machine. It's like a screen touch. Surface property or texture is an important factor for many applications in modern technology. It affects the feel of a product. It's usually and it's overall aesthetic. When the finger contacts the surface, analysts electronic attraction force is weight between the finger and the surface. The low force requiring high voltage signal amplitude are the drawback of the method. So here is my experimental setup. The developer tactile is capable of providing three factors of perception, as you see here in the picture. And airflow was applied to create a sense of touch here. Hot and cold sources were used to create temperature gradient, and other sources were interacted to provide affliction. Here in cold source, hot source is two pump. I will speak about it later. The device and its schematic representation are shown in figure this. The whole system was controlled using Arduino Uno. So, conceptual design. What I use Aperture. The Aperture effect is an interesting phenomenon in which electric current applied through two dissimilar materials can cause one side to reach a significantly high temperature than the other. I use also pumps. The 12 volt pumps is one of the more common type of pump available, and they are widely used in a variety of applications, from medical equipment to agricultural irrigation system. These pumps are known for their low power consumption, small size, light weight, and property. They are proud either the 12 volt DC battery or 12 volt transformer. So user study. The performance of the system was tested with a temperature source, hot and cold, and two odors, pleasant and unpleasant. A combination of stimuli was utilized. Subjects were asked to write experienced condition with A hot, with H hot, and C cold, P pleasant, and U unpleasant. So here, how we have created the thermal feedback. As you see in the picture, I have a box. Inside this box, we have Aperture. As you see here, I have two pumps and relation with pipes. So in our example, we have two boxes, and inside these boxes, we have two Aperture. One of them cold, and the second is hot. There is also an aluminum layer inside this. The boxes here, we have aluminum to maintain the temperature. I have connected these two boxes with two pumps, as you see here. One of them give air cold and the second give air hot. And in the middle, I put a touch screen to sense the temperature. And I have connected these two boxes with two pumps, as you see here. Yes. How we have created a touch feedback. The tactile surface is composed of 70 millimeters, 60 millimeters per 10 millimeters surface. It consists of 110 holes on the surface. Here in my surface that I have showed you. The diameter of each hole is about 1 millimeter. The distance between two holes is about 5 millimeters. The air was pumped using this pump and transmitted to the surface using pipes with 5 millimeters diameter and exist from the holes. Now, how we have created the sense of smell. So I have connected this, as you see, these two boxes. I connect these two boxes with one pump, and also I use pipes to make a relation between boxes and the screen. Here, the relation between these boxes and the screen. The screen this perfume comes out from this screen. Yes, and I can smell like this. So result and discussion. According to the obtained result of the participants, were able to recognize the difference between pleasant and unpleasant sound. However, 40% of subjects were able to correctly distinguish hot and cold streams. The main reason for this could be lost due to the design of the source storage system, piping and isolation in the system, which require keeping source closer to the destination point. Regardless of the temperature, all of the subjects were able to feel the airstream as touch feedback. The main shortcoming in touch was stated to be the intensity, which require powerful pumps with higher pumping capacity and design improvement. This is simulation results. In my case, we have temperature. I used cold and hot. About observation, it's about 0 to 10 degrees Celsius, and hot from 30 to 60 degrees Celsius. And the smell, we have perfume A and perfume B. I could smell perfume A and perfume B. And about the touch sensation of finger attraction and the feeling of pushing my finger, as you see in the picture. About this conclusion, a novel method to create a sense of touch, temperature, and offlection was introduced. The air stream was employed to create a sense of touch. The thermoelectric device was used to create a temperature feeling using convection air transfer. Two other sources were utilized to create a sense of smell. The performance of the system was tested through users' evaluation. The device showed acceptable achievement. The process concept could be integrated into the current haptic device, where building a multimodal haptic system is important. About the future work of this method or this machine is development of method to maximize the diffusion of air and aroma molecule in a dynamic and spatially precise way. Developing method for controlling the concentration of air and aromatic substance relation. Explores method for sensing and controlling the density of substance and air that flow through a chamber. Improve the integration of air and aroma molecules with exciting tactile display technologies. Method for controlling airflow near or through the user's skin. Explore further the connection between offlection and tactile sensation. Thank you for your listening.
Thanks for your presentation. dear Harun Boğcelal. Dear participant, do you have any question about the article? Okay, no question. Thank you again. I wish you success in your career, dear Harun. Dear Sazad Islam, are
Yes,
you ready to present?
yes, I'm ready to present. I'm going to share. Thank you.
You have 10 minutes, please.
Okay. Can you see the screen?
Yes.
Wait. Okay, I'm going to start. I hope it is all visible and you can hear me clearly. Good evening, everyone. It is a great pleasure and excitement that I'm here to share our research exploring uncharted architectural territories through generative adversarial network with human collaboration. My name is Sajjad Islam. I am an architect and a student of computer science at University of People. This research is conducted by me and my partner Ashik Bhaskar Mannan, who is associate professor at American International University, Bangladesh. So here is the index of what I'm going to cover in my presentation. Let's start with the background and motivation. From my country, Bangladesh, it started like 2021. We suddenly noticed that AI is everywhere and decided to do something with it in architectural design realm in our context. So why in artificial intelligence? Undoubtedly, this is a revolutionized approach, and this is a revolutionary approach and innovative design possibilities. Neural network enables the generation of novel form, and it also unconventional architectural forms, pushing the boundaries of traditional design approach. Neural network inspire architects to think outside of the box, fostering new ideas and design concept. For example, AI-powered tools can generate endless design variations, simulating creative thinking and exploration. And also it is actually a collaboration between human and machine. Neural networks complement human expertise, acting as creative assistant and expanding architectural possibilities. For example, architects can collaborate with AI algorithms to explore design iteration and combine their artistic vision with AI-generated suggestions. So that was our motivation of research, and let's move to okay, our research objective. So the main objective was was to evaluate the use of architecture-oriented data set. Specifically, we aim to achieve the following achievement, like evaluating the suitability of popular data set for architectural design and determine the necessity of architecture-oriented data set. Also, we try to evaluate the effectiveness and the quality of conceptual quality of conceptual design in architecture, investigating the potential of AI for personalized architectural design, since each architect have their unique philosophy and artistic perspective. By achieving these objectives, we hope to gain deeper understanding of the potential of AI in architecture and how it can be used to improve design process furthermore. So now let's go to our methodology. In our methodology, moving on the methodology section, I will provide an overview of the approach we followed in our research. Our goal was to explore the use of a neural network, particularly generative adversarial network. In short, we call it GAN, and this to generate futuristic architectural form actually. Because we always see the past, how about the future? How can we investigate through the machine? So it was like whether machine can generate novel architecture form through the creative data optimization process. Now let's dive into a specific step that we undertook. Firstly, we collected diverse range of architectural datasets from reputable sources. These datasets include popular collection of Splicker, AD20, WikiArt, Coco, ImageNet. We took both the 1024 and 384. And these datasets serve as a foundation for our neural network training. For our experimental setup, we utilize an open source notebook developed by Catherine Carlson, a leading expertise in the field of neural network. The notebook was specifically designed to implementing generative adversarial network and provide a user-friendly interface for our research. We conducted our experiment in Google Colab environment, which offer necessary computational resources and infrastructure for training and evaluating our neural network model. This combination of open source notebook and the Colab environment provides seamless, efficient platform. So, and we also took a study subject, which is Shat Gambuz Masjid. In English, it's like 60 Dome Mosque. This is a historical landmark in our country. So we picked this to test our experiment. Before I'm going to start, I think I should speak about the basic concept. The GAN actually developed by Ian Goodfellow and his colleague in 2014. Back then, it was more like very basic. So how it worked, GAN actually work. It's a type of machine learning framework consisting of two neural networks, a generator and discriminator. This is the main part. The purpose of GAN is to generate new data that closely resemble a given training data set. The generator network learns to generate synthetic data samples such as image or text by mapping random noise to realistic looking output. On the other hand, the discriminator network learns to distinguish between the generated samples or real samples from the training dataset. We will describe more from the next sequence. These two networks actually train simultaneously with the generator, aim to produce output that a discriminator cannot distinguish from real data. So through the iterative training process, the generator and discriminator engage in a competitive adversarial relationship. That's why the adversarial word actually came. With the generator constantly improving its ability to produce more realistic sample, the discriminator become better at distinguishing between real and generated data. That's how it actually works. This competition drives the GAN to generate increasingly convincing output. So let's see the process. So if you see that we have the data set and that we pass into the GAN, is GN actually a generative adversarial network short form, and N is actually the generator, and this discriminator, and generator actually pushing, creating the images, and discriminator actually telling that whether it is fake or real. Then it goes to the discriminator, and each time discriminator say that this generation is failed, it's not close to the what architect wants or what the actually we given the input. So then they start iteration, and each iteration they actually go close to the they actually create a visual part features. So how it understand, like in this photo we see that it actually defines is fast, and it actually part by part it hold the pixel to generate. And each pixel actually have RGB channel, and it actually distinguish from that. And then it actually flatten the pixel, and then it go to back propagation by layer. That's where actually perceptron neuron actually collected those layer for the result that we desired. And finally, we get output that we were asking from the computer. In the machine, it actually give result mostly that are not we are looking for. So that's why maybe we the human, we are not a good generator. We are good as a discriminator. We good judge, like distinguish as a juror. We can say it's fake or it's not in my philosophy. This is not what as an architect want to design. So we choose by selecting image, and we it's like we are not good cook, but we can taste and immediately say good or bad. So we control the iteration stage and tell machine what we want. So let's see the how actually we go through the process. The process involves actually multiple iteration, and this iteration actually controlled by us human or the design. And this collaboration where we actually adjust various hypermeter, as you can see, the taste, with height. And this approach, we observe the evaluation of generation. And sometimes that we do not proceed, then this red line is actually that we end this iteration and we move to the other model and put the last iteration that we want to develop from this. And then if further we actually go to more, we observe the evolution of the generated architectural form and sought to achieve more desirable and innovative outcome. So let's move to the result section. So before we going to that procedure, we actually tested and defined some of the result that actually we are going to use, and we actually compare those. So this is the first line that we are seeing, that red mark, that we let the machine know, let the machine generate without letting it know the image. So without the image, it actually formed very ambiguous and abstract, not our desire. So we let it learn the short gambut mosque, and then we found better result. And also we defined that how different model, different data set actually producing different shape and outcome. And here is actually our outcome. As you can see, this is actually one part of our study. It's good enough to explain what we try to do or our intention to do. It will take some time to reach it because the iteration actually took like more than 2000 iteration, I think. And also we had to change the parameter in different times. The specific reason why you choose this Shad Gambut Masjid as our experiment, I mean this building, why you choose this, because due to its strong iconic structure that has been tested by time, because it's it actually is structure from 300 years ago, maybe it built. So we wanted to explore how AI can generate new and innovative design while staying true to the architectural heritage and historical structure like this mosque. I mean, it's our context and our philosophy to way. I mean, giving the direction which way we want to go for it. And there is some limitation, and the data set limitation. The availability and quality of architectural data set can cause a limitation to training of neural network. Limited or biased data is impact the diverse accuracy of generated design. I think near future we are going to improve to get better result. At least we can actually overcome the data set limitation near future. Also, the computational resource, we know that training neural networks, especially with large data set and complex architecture, requires significant computational resource. So it has some limited. We had this limitation for limited access to high performance computing infrastructure that can constrain for us. However, it is important to acknowledge that near future we will overcome this limitation and get better result. So I will go to the conclusion, and I want to actually remind the capability of tools influence the craftiness of designing plan. Or in any cases, if we see the historical chronology, the tools matter. How? In 1820, we see that we had ruler, set square, protector to design, and that's why we got this kind of design or plan or architecture. And then in 19, we developed developed the drafting table to make a straight line. Then we get this kind of design. After that, we got flexible curve drawing tool. So our plan start to become bend. We can do curve design. Then we got our computer, and we suddenly also we got 2005 the 3D printer. Now we actually able to conceptualize three-dimensionally in the design area. And now we have artificial intelligence. So now we can go beyond what actually did before. So that's everything for now. Thank you. Any question, I'm ready to answer.
Thank you for your presentation. Dear participants, do you have any question about the article? Okay, no question. Thank you again. I wish you success. Dear Shaikh Balekuddin Kashif,
Good evening,
are
sir.
you ready to present?
Am I audible, sir?
Okay.
Just a minute, sir. I'm sharing my screen.
Okay. You can share your screen.
Is my screen visible, sir? Can you please acknowledge?
I can see your screen. Please, you have 10 minutes.
Okay, sir. Yeah. Good evening, all the panel members. I am Sheikh Balikuddin Kashif from India. I am an undergrad student of B.V. Raju Institute of Technology from the Department of Electronics and Communication Engineering. This project is our research work from the past 2 years as part of our undergrad degree program. The title of this project is Object Detection System in Self-Driving Cars by Calibrated Camera and LiDAR Data. That is by implementation of the hybrid point pillar method. So now we'll move on to the abstract. What is the abstract of what is the purpose of this project? So we can see that in these days, the self-driving car technology is growing day by day. A lot of research is going on. A lot of institutes are sponsoring a lot of researchers, and we are getting a lot of things. So new innovations are getting out. So that's what we wanted to contribute to this domain, and we have selected this project. And what we are using it here, that is for the self-driving car, what is required. So when we are eliminating the driver, so the process is automatic. That is the automation system. For that, we will be using AI-like tools like neural networks. We will be using artificial intelligence, which will be able to make the decisions on its own based on the environmental conditions, physical and environmental conditions around the vehicle. And how we are going to do this? So we will be using two different sensors. That is, firstly, we are using the camera, and the secondary we are using is the LiDAR. So how we are going to integrate both of these is by calibrating both of the sensors with each other, and then collecting the data and framing it. Both the frames we are merging it and making it into a single frame, and that we will be training by using some data sets. So in this project, we have used two different data sets. That is the Kitty data set and the Coco data set. So we have used one set of data set for the training purpose and to test the accuracy to find the better approach, like whether this will be working in the real-time environment or not. So for that sake, we have tested it on the other data set. So for training, we have used Coco data set, and for testing, we have used the Kitty data set. Now moving on towards the introduction. So what kind of detection we are doing it here? Like as I already mentioned just now, that we are calibrating the sensor data, that is the camera data and the LiDAR data. Now we will be using the deep learning methods here, so that the AI can do the decision making process. So here we will be using two different algorithms. So we are merging them and making it a hybrid model. So till now in the market, the existing researchers, what are going on, they are on the single algorithm. So we are making a hybrid model of that, which is the uniqueness of this project. So the two algorithms which we are using here are, first is the faster RCNN method, and the second is the point pillar method, which is based on the PointNet algorithm. So let's move towards the literature survey. So what is the research we have done? What is the literature survey we have collected from the others research, what is going on, and we decided what extra we have to do. Like first is the thing, the object detection techniques. Like we need to check on what are the available object detection techniques in the world today. Like whoever is doing the research, that may be the institutes, that may be the MNCs, any company, organizations, whoever is doing it, what kind of object detection techniques they are using. And coming towards the second thing, as we are using the sensor, so what kind of detection algorithm we are using for that particular sensor, like LiDAR. We have different algorithms for detection algorithm for the LiDAR sensor, that is complex YOLO, point pillars, PointNet, and all this. That will be run on the convolutional neural network. And coming towards the camera based detection algorithms, so we have different camera based detection algorithms. So that will be RCNN, that is the advanced regional convolutional neural network, which is one of the advanced algorithm. We have an algorithm called YOLO, you only look once. We have single shot detector, and many more like that. Now talking about the data sets. So we are using Kitty data set, which is officially provided by the Toyota Technological Institute, and this is a very huge data set. And this will be used, Kitty data set will be used for the testing of the final model. Now coming towards the Coco data set. So Coco data set is used for training of the objects and generate a AI model, like the hybrid model which we were discussing. Now, what is our proposed method? Like in this block diagram, you can see the left image, which is taking the image input. This is the faster RCNN network. It is taking the input of an image with some particular resolution, and it is dividing it into the pixels. Now, after dividing it into the pixels, ROI pooling is done. ROI is region of interest, like what we are detecting. So we are passing an annotation file which consists of the data that in the given data set where the objects are located right now. Like we are giving an image, we are giving the annotation file of the image. So AI is seeing the image, it is checking the annotation file, and it is marking the coordinates in the three-dimensional axis. Because we have LiDAR data which gives us the three-dimensional frame, and the camera data which gives us two-dimensional frame, when it is calibrated, in the three-dimensional environment, we will be creating the multiple frames. Like one frame is of the LiDAR, one frame is of the camera, and we will be calibrating it. We will be getting three-dimensional coordinates, and out of that, we will be getting the bounding boxes of the object. Now, the AI model, like faster RCNN, which we are using, it start extracting the features of the bounding boxes, like whatever is present inside the bounding boxes, it start extracting those features. So what kind of objects it is detecting? We are providing it some classes. Like in this project, we have given only 3 classes. The first one is the cars, the second is the pedestrians, and third is the cyclist. So we generally see these 3 classes of categories, these 3 classes on the road. Like we see a lot of cars going, a lot of cyclists going, and a lot of pedestrians going. So that is the reason we have chosen these 3 classes, and then we have provided data for these 3 classes. Now AI start extracting the features of the car, and the features of this pedestrian, and feature of the cyclist, and it stores it. Like we are giving the data of 3000 images. We are going on training it, keeping iteration, that is 160 approaches we have trained. And when we got some poor result, like not that accurate, then we have trained it up to 300 approaches, and then we have generated a model. For that, we will be doing the testing using the point pillar RCN method, sorry, point pillars method. So that is the backbone for the detection system. Like we are giving the data, and it is going to the backbone 2D convolutional neural network. Now that is getting splitted. Whatever the image input it is taking in the real time, that will be getting categorized into the pixels. It will be categorizing into the pixel, then it will be generating the ROI format, and it will be concatenating all the others. Like when it is splitting it, now at the end it will be concatenating it into a single image again, and it will be giving it to the detection head. The detection head identifies the output annotations, and it will mark the bounding boxes, and finally it displays the predictions to us on the screen. So this is the implementation of the project. The right side, the picture, you can see how we have organized the data set. Like we have the training folder, we have the testing folder, and each training and testing folder, we have 4 different folders, like Velodyne, which consists of LiDAR data, image _2, which consists the camera data for the front part, front of the vehicle. Calibrated data, it has the coordinates, like how much is the distance between the LiDAR and camera, and how it needs to be calibrated for that particular image. And we have the labels, like what all the labels are there, like what all the objects are detected in the annotation file, that will be in the labels file. The same we have in the testing data, but in the testing we don't have the labels file. Like we directly get an output. So to obtain the percentage, like how accurate our trained model is, then we will be giving the labels file, and we will be cross checking, like whether the output is correct or not, the obtained output is matching the labels file or not. If it is matching, we will be giving it as this is the AI have detected it correctly. If not, we will say that what is the precision, like how much is the correctness and how much is the loss. In this way, we categorize the accuracy percentage in this method. Like here we'll be using the pillar feature encoder. It is a deep neural network that takes in pillar data that is obtained by the pillarization. This is the part of the point pillar architecture. Like it will pillarize the features first, and then it does the detection. Next we have the regional proposed network, and in this network it consists of a set of convolutional layers that learns to identify regions in 2D images. Like we have used the camera data as well as the LiDAR. So it because of this regional proposed network, the AI model tries to learn from the 2D image data as well, not only from the 3D by the coordinates, but also from the image data. Now coming towards the non-maximal suppression, what it does is it sorts the proposal by the confidence score and applies NSM to the top scoring proposal. Like it means the confidence of the level. This is at the end, like while we are testing it, we will be checking the confidence, like how accuracy is it. Like I said, we will be cross checking it with the label file, so that we will be getting to know the percentage. So this non-maximum suppression does that thing, like checking the precision, how accurate the obtained results are. So these are the output values, output images of our project from the Kitty data set. So the left image is the picture number 7 in the data set, and the right image is picture number 4 in the data set. As you can see, the in both the images, the top section is the camera view. That is, it is detecting the bounding box obtained are from the camera data. It is processed, and this is the output we got, and the below image is the LiDAR data. We have converted 3D LiDAR data, like at the end while displaying, we have converted it into 2-dimensional format, and we have taken the top view of the front portion. Like whatever the area is covering in the camera data, the same area we have taken it in the LiDAR data, and we have made the top view of this, and we are detecting it and marking the bounding boxes across this. So now let's talk what is the exact thing we have got. So the others work, we are comparing here the others work versus our work. So now the first in the first row, we can see that when purely point pillars is used, the mean average precision for all the classes combinedly was 66%. And when purely faster RCNN method was used, the mean average was 58.50%. But when this hybrid method was used, the mean average is extended by 4% more. Like that is, we got 70.80%. And like we can compare it with the individual classes as well, like cars, cyclists, and pedestrians. Like we have obtained the high accuracy for the cars, that is the 87.30%, and we have got lesser percentage in the cyclist and pedestrian. This is because of the lesser data set, because it didn't get trained well. Like if you are providing it with the more data set, then we can improve the accuracy of this percentage as well. So here is the plot of our obtained results. Like we can see the average precision and the mean average precision. So of we are getting the highest average precision for and mean average precision for the cars, and it is reduced in case of cyclists and pedestrians. So this will be discussed in the future work, what need to be done to improve this. So coming towards the future scope. So what is the future scope of this project is, more data need to be provided to the training model, like to the AI. More data need to be provided by attaching multiple sensors such as radar, ultrasonic sensor, and many more such sensors we can be providing to it, and so that it the lot of data gets trained, and it does the detection more accurately. And coming towards one of the future scope, one more future scope, that is we have only provided it the 3 classes. Like we can see there will be more number of objects on the road. We can consider the trucks, commercial vehicles, private vehicles, buses, and all. So we have not done the detection for those things. So this will be the future work. Like if someone want to continue the work and improve this model a lot, then they have to consider all these extra classes whatever are available on the road, and give the huge data set and train it, and then testing those things can obtain good result. And finally, coming towards the conclusion, like we have reached the aim of this project. Like we wanted to contribute to the self-driving car technology by making a hybrid model architecture, and increase the accuracy of the object detection system using the LiDAR system. So here we have used a faster RCNN method and the point pillars method, and we have used 2 different data sets, that is COCO data set for the training and Kitty data set for the testing. And we have ran this sample test cases and differently in the different data sets. and we have obtained the better results when compared to the individual algorithms. So this is what we want to conclude. These are the references what we have referred before starting this project, like what others are working on. So that's it for this presentation, guys. Thank you. I'm open for questions.
Thank you. Thank you for your presentation. Dear Parsim, do you have any question about this study? Okay, no questions. Thank you again. I wish you success.
Thank you, sir.
Dear Shiva Shashank Davala,
Yes, sir.
are you
I'm-
ready to present?
Yes, sir.
Okay, you can share your screen and then start presentation.
I hope my screen is visible,
No,
isn't it?
you must share your screen.
Yeah, just. I don't think it's getting shared. Is it visible now?
No,
Okay, I've logged into.
can you share your presentation?
Yes, just a minute.
Okay. I can see your presentation.
Yes. So sorry for the glitch. I don't know why I was not able to detect through my primary laptop.
You have 10 minutes, please.
Yes, sir. So greetings one and all. I am Shiva Shashank Dhavala, and I am an undergraduate student in Rashtriya Vidyalaya College of Engineering in Bangalore from India. The work that I'll be presenting today is an extensive review of applications, methods, and recent advances in deep reinforcement learning. I'm not the only one who has worked on this project. I was privileged to work along with Sri Harisi, who happens to be my batchmate, and two of our professors, Professor Vani Shrike and Professor Rashmi R. And this is a review paper, an extensive review paper that we've worked on. And the unique contribution is that we have tried to do a review in a domain that is not much explored at the moment, that is the application of deep reinforcement learning, specifically in the sector of video gaming and how video gaming is used to test control problems. So this is how the agenda for the presentation will look like. So from I'll try to take it from the very bottom line, and I think there are three major key terms that need to be discussed before I go ahead with our analysis of deep reinforcement learning in the video gaming sector. So I think the three important terms are deep learning, reinforcement learning, and then deep reinforcement learning. So AI and ML have changed the way we live, and I think there has been a great advancement in the terms of how ML was the buzzword. Now DL and RL are the buzzwords, or most of the solutions that are being worked on are in the domain of DL and RL and no more ML. So with advancement in time, technology, data availability, systems are able to solve more and more complex systems. ML was solving smaller problems. DL takes up higher level tasks, and RL is trying to make systems learn the way humans learn. That is, interact, receive feedback, and then optimize. So if we look at a lower level picture, we get to know that deep learning involves training neural networks with multiple layers to extract complex patterns and make predictions. RL is where we have an agent in an environment. It receives feedback in the form of rewards. This can either be positive or negative, and it learns optimal behavior from that. And DRL is a new and upcoming field where we try to combine deep learning and reinforcement learning. The reason why this is done is something that will be the major focus of my discussion in today's presentation. So in order to understand why deep reinforcement learning is important, I think it is also important for us to understand what deep learning is capable of, what RL is capable of, and what are the shortcomings individually, and how can they perform better when they're combined. So if we look at it, if we look at deep learning, I think most of us know that it is a subset of machine learning that focuses on training deep neural networks with multiple layers. So that's the major difference between a plain vanilla machine learning algorithm and the deep learning algorithm. That is, you have more layers, or you have more layers through which your weights or your data goes through. Hence, your systems are more robust. Hence the point, and it is an enhancement on traditional machine learning. So one advantage of DL is that it can automatically learn hierarchical representations from raw data. Now, what do I mean by hierarchical representations of raw data, and what can it do? I think when I say it can learn hierarchical representation from raw data, it can discover complex patterns and features at different levels of abstraction without explicit feature engineering immediately from the raw data that we have. So an example for this can be when we have an image recognition task. A vanilla machine learning model, what it can do is it can probably detect edges, and based on the shape of the edge, it can give an output. But when it comes to DL, we move deeper into the network with the data that we have. The neurons in the network can learn to detect more complex patterns, not just the edges, but more complex patterns like curves, textures, and shapes, basically designed to exploit the spatial hierarchies in the images. So what is the advantage that was seen? ML methods are more time consuming because of the feature engineering that needs to be done, and less efficient. DL can learn these hierarchical representations, which enables them to extract meaningful and complex features from raw data itself. Hence, it is much faster and a more robust way to do it. So this is a very high level idea as to how deep learning helps us in many of these intelligent tasks that are being done in status quo. Now, if we have a look at reinforcement learning, right? So this is basically a paradigm where we have an agent, it interacts with an environment, and it learns through trial and error. And this learning component is through rewards, which can either be positive reward or a negative reward. And the end goal of reinforcement learning is to maximize the cumulative rewards by taking appropriate actions in different states. If we try to look into what RL is, I think there are 6 key components or 6 key elements of RL. That is an agent or an entity that learns and takes actions in the environment itself, that is the context in which the agent operates, state, snapshot of the agent in the environment at any given point in time, actions, that are the legal steps that can be taken, rewards, that is the feedback signal given for every action that the agent takes, and policy, which is the most important part of RL, that is strategies used by agents to determine actions based on the states. Now, if we look at the kind of algorithms that are used within reinforcement learning, there are many that have come up with advancement in research, but few of the main ones are Q-learning or Markov decision processes or and policy gradients, right? So these are all different algorithms, but what we need to understand is all of them have one commonality between them. That is, they need to store rewards or the policy outputs to refer back to the cumulative rewards and decide the best sequence of actions. That is, there is a sequence of actions that take place, and at the end we need to give a reward based on the output. Now, because this is an entire sequence, we need to have a reference to always refer back to and decide which is the path that we want to take the next time. So we need some sort of reference mechanism. For example, Q-learning maintains a tabular format for reference and makes decisions based on those computed values. Now, let's assume a case where we have a very large feature space and the tables that we are trying to deal with are also very huge, both in size and number. Then the efficiency of the entire system goes down drastically, and there is literally no use of going for reinforcement learning when we have such non-robust systems. So now we kind of understand the power of reinforcement learning, at the same time the shortcoming of reinforcement learning. That is, when we deal with very large feature spaces, the time consumed is very high and the efficiency of the system is very low. And that is where we sort of come to an idea that we need a mixture of the deep learning, where you have a very quick and fast hierarchical learning methodology, and RL, which is very robust in terms of learning based on the rewards that are given. We kind of get an idea that when we combine these two, we might get an optimal result. So let's just see how this is implemented. So DRL is nothing but the combination of deep neural networks with reinforcement learning algorithms. So like I mentioned, you have these value functions or the policy functions which give you outputs, or which give certain values which have to be referred at later stage to make a decision. In spaces, in large feature spaces, when these are many in number, it becomes very hard for the user to draw any inference from this. Hence, in this part of reinforcement learning, a deep neural network can be used to approximate the value functions or policy functions in RL. So that kind of makes the entire problem of having a large feature space in RL a smaller problem. Why do we do that? Because deep neural networks in RL can enable end-to-end learning. That is, we can skip the intermediate step of feature engineering and learn directly from raw sensory input and give it to the network and get a feedback. Based on that, we can tell the system whether or not it is the right action to do. So like I mentioned, deep reinforcement learning can be used to handle high dimensional input spaces. So again, partly what we have discussed, but I think this is important to discuss why deep reinforcement learning is required to analyze how it is being used in the sector of video gaming, right? So what is the problem that exists? Traditional approaches face numerous challenges in complex and high dimensional environments. So the problem is with feature engineering and representation learning in complex domains. It becomes a manual, laborious, and a very slow process. The other problem is limitations of tabular representation in high dimensional state and action spaces. So this occurs in reinforcement learning, right? This problem. So DRL addresses these challenges through its ability to learn complex representations. A deep neural network can automatically learn the hierarchical representations from the raw input. So this is what we have discussed from the first slide where I spoke about DL. That is, it has the ability to learn hierarchical representations. This allows agents to capture intricate patterns and relationships in the environment. So the agent using RL does what it generally does, and we are using a deep neural network to run all our inferences or analysis on the values that we are having to store to run an inference. So with building upon all this, I think we'll just move on to the case study, that is video gaming. Many of us have played Atari games in our childhoods, and Atari games are not just for video gaming, but they have been largely used by AI researchers to test control problems. So the goal of researchers in the recent past has moved from achieving human level performance to superhuman performance in these gaming situations, because these can also be extrapolated for testing control problems. So if you look at the screen, there is an illustration of the game of Pong, right? So just for the benefit of the room here, we'll just define the entire environment that exists. The agent here is a paddle, or the user that is controlling the paddle. Let's just say the one on the right. The environment is walls on the top, no walls on the left and right, and two paddles and a ball. If the ball is missed by any paddle, the ball goes out of the reference frame. State, there are only two states that exist for any paddle: hitting the ball or waiting for the ball. The actions are that the paddle can move either up or down. That's it. What are the rewards? If it wins, we get a +1, but if it misses the ball, we get a -1, or the opponent gets a +1. In either way, if the ball is missed, it is a penalty. If the ball is struck and the player wins, it is a positive reward. And what is the policy? The policy is to accumulate as much as positive score or positive reward as possible. So based on this entire setup, the Pong game functions. Now let's just assume there is a supervised learning scenario in this setup. There are various problems that come about. That is, as mentioned in the slide, the human controlling the agent must be highly skilled in order to get high performance rates. The data set created must be large enough to cover all possible action sequences, which is very, very difficult. Since the model is trained on a data set created by a human, the model can at best perform equivalent to a human, but never better than human. Hence, reinforcement learning is used. The framework used in reinforcement learning is here. We have an input frame. In the middle, we have a neural network, and we have an output action. So the neural network that is generally used in video gaming is policy network, which is trained using a method called policy gradient. So what basically happens is we take a random network state and it is sent to the network, and now the game is started, and the agent has two options to either go up or down. It takes one of the actions, and a reward of +1 or -1 is given. Based on that, the system learns. But what is the end goal? The end goal is to maximize reward. Now it seems all easy and dreamy, right? But there is one problem that comes about in reinforcement learning, that is the credit assignment problem. So if you look at the image that is being projected right now, there are 4 different scenarios where only 2 of them, the agent wins the game. So according to the definition that we've given till now, +1 is given only when it wins and -1 is given when it loses. Now consider the middle 2 cases where it loses. Just because it lost in the last step, it doesn't mean the entire action sequence is wrong or is something that is not favored, or it's something that's desired. It means that at some point in the entire sequence, there was a mistake or there was a wrong move, hence it went wrong. So this is called the credit assignment problem. If we just use, say, reinforcement learning, what we do is we discard the entire action sequence just because we have a -1, but that is not optimal. What we need to do is to solve the credit assignment problem, and this can be done when deep reinforcement learning is used. That is when we use deep neural networks on this entire setup that we have, because we'll have to save a lot of environment state variables, and we'll have to keep track of the state of the agent and the score or the Q values that are being given. And this is very large amount of data. This is where deep reinforcement learning can be used in order to come up with very, very strong and robust systems. This reduces the time consumed. If we just use RL, it takes a lot of time because we have to consider multiple scenarios. We use deep learning methods on the RL state or the table information that we have to train this in a very robust way. So drawing up on the same example, I think the idea of Montezuma's Revenge, this is also a game, an Atari game, but this is a lot more complex than just the small action space that we have in a ping pong game where it is only up or down. If you see, the entire environment is complex here, and there are billions of action sequences possible. Just because one step goes wrong at the end doesn't mean you can discard the entire action sequence. So you will have to keep track of the entire sequence and know which exact step went wrong for the agent. Only then you can carry out this training in a very efficient way. And another problem that comes up with such complex games is there is a sparse reward problem. When we say sparse reward problem, the probability of you getting an entire action sequence that gives you a +1, the ratio of that is to the probability of getting an entire action sequence that gives you a -1. It is of the order 10 power -3. That was that was the result of a research. So in such cases, it is very important that deep reinforcement learning is used. So that was a high-level idea as to what we carried out during our study on deep reinforcement learning in the field of video gaming specifically. But if we look at few future directions, sample efficiency is one thing that has to be worked on. Like we mentioned, the amount of data that's required is huge, and we need to increase the efficiency of the samples we have. Next is reward shaping. That is also related to the credit assignment problem that I was talking about. Just because there is a loss at the end of the entire sequence doesn't mean we discard the entire thing. We need to find out a way in which rewards can be given so that the part of the action sequence which was leading to +1 is still credited, and the part which has led to -1 is discarded. Next and most interesting part of this entire field is explainability and interpretability. Most RL models or DRL models are considered to be black box models right now, and people do not know what's happening inside. So we need to work on having explainability of these models. And then both the examples that I've spoken about today are single agent reinforcement learning. Future direction is towards multi-agent reinforcement learning, where there are multiple agents all trying to learn at the same time using RL or DRL. So that sums up the work that we've done. Thank you all for being such patient listeners. I am ready to take any questions if there are any. Hello.
Thank you for your presentation. Dear participant, do you have any question about study? Okay, no questions. Thank you again. I wish you success, dear Shiva Shashank Davala.
Thank you.
Dear Ali Happonen.
Hello, can you hear?
Yes.
Yeah, my name is Usman Ahmed Usmani, and I'm going to present the work.
Okay.
Yeah, just
Okay,
I'm
you
sharing
can
my...
start your first
Yes, sir.
presentation. There are 2 presentations, okay?
Yes, sir. Yes, sir, sure.
You can start. You have 10 minutes, please.
Yeah, can you see my
Yes,
screen?
I can see your screen. Okay.
Sure. The topic of my presentation is human-centered artificial intelligence designing for user empowerments and ethical considerations. And my name is Usman Ahmed Usmani, and I am currently working as a postdoctoral researcher in United Arab Emirates University. And coming to the contents of this work, we'll first go through an overview of human-centered artificial intelligence. Then we will briefly introduce it, then to the user empowerment, and then we'll go to the ethical considerations, and then how the human and AI collaboration, the factors that affect the human AI collaboration and interdisciplinary collaboration, and then creating a future with AI. And now coming to the introduction, the human-centered AI focuses on designing AI systems that prioritize user empowerment and ethical considerations. So with this work, we explore the importance of user-centric design principles, and then we propose the ethical guidelines that can be used in the AI technology. And it emphasizes the user empowerment through personalized experiences, and it includes the fairness, transparency, accountability, and privacy protection. The effective human-AI collaboration contribute to advancing human-centered AI, which can benefit the humanity and promote the societal well-being. Now, coming to the user empowerment, it is a key aspect of human-centered AI, where in terms of personalized experience, the AI systems can be designed to tailor their functionalities and recommendations according to the specific needs and preferences of individual users. And in terms of the explainable AI, users often desire transparency and understanding regarding how AI systems make decisions or provide recommendations. So these techniques can enable the user to comprehend the underlying process and the factors that can influence the AI's output, and then fostering the trust, which is crucial for the acceptance and effective use of the AI systems. And it involves establishing the trust by ensuring the reliability, accuracy, and consistency of AI technologies. And in terms of user agency, it refers to the user ability to actively participate, influence, and control the actions and outcomes of the AI systems. And the benefits of user empowerment are that AI system can lead to increased user satisfaction, engagement, and loyalty. So with the benefit of this, of the user empowerment, it can help bridge the gap between human and machine intelligence. So it can make people more confident about using any AI technology. Now coming to the ethical considerations, which we propose, is coming to the fairness, that ensuring fairness in AI system means avoiding the biases and discriminatory outcomes. And the technologies should be designed and trained to treat all individuals fairly, irrespective of their race, gender, and age. And transparency in AI refers to making the decision-making process of AI systems understandable. And coming to the accountability, establishing accountability mechanisms ensure that error, biases, or negative impacts can be identified and addressed. And in case they can be, if they are implemented wrong, they can be rectified appropriately. And the privacy protection, which involves respecting the user privacy. It is very important in while designing any AI systems, and it includes the secure data storage, consent mechanism, data anonymization. So all these processes and these steps should ensure that the privacy is protected for the user and avoiding any harm, which involves that the ethical AI system prioritize the prevention of harm to individuals. And coming to the data governance, also encompasses responsible data governance principles, where the clear guidelines and policies should be established for data collection, usage, sharing, and retention. And coming to the human rights, AI system should respect and uphold the fundamental human rights. This includes principles such as non-discrimination, privacy, freedom of expression, and due process. Now coming to the human AI collaboration. Human AI collaboration emphasizes involving the users in decision-making process alongside AI systems, and it recognizes the importance of user control over AI systems. And human and AI possess distinct strengths that, when combined, can lead to more effective outcomes. And AI technologies can provide users with insight, recommendations, and analysis to support the decision-making process. And coming to the contextual understanding, AI systems often lack contextual understanding, which human process. So it allows the users to provide essential context. And in terms of user training and education, it involves training and educating users to effectively interact with the AI systems. And in terms of user experience design, collaborating between human and AI requires user experience design. And coming to the interdisciplinary collaboration, the points we propose is that in terms of user training and education, human AI collaboration involves the training and educating the users to effectively interact with the AI systems. And users need to understand the capabilities, limitations, and potential biases. And in terms of user experience design, the collaboration between humans and AI requires careful user experience design. And in terms of building trust, when user will trust the AI technology, they are more likely to collaborate and rely on their outputs. And bridging the gap between the academia industry, the policy and regulatory considerations, where the collaboration will help to anticipate the potential challenges and propose appropriate regulations. And coming to the ethical review board and committees, these boards consist of experts from various disciplines, which ensure a comprehensive evaluation of the ethical implications. And coming to the holistic impact assessment, these assessment will help in identifying the potential risks. And now creating a future with AI AI disciplinary collaboration. The positive impact is that it has the potential to create a positive impact on society. And in terms of human aspirations, AI should align with human aspiration and goals. And it should empower the individuals by providing them with tools, information, and resources to make informed decisions. And it should contribute to economic growth and job creation by automating repetitive tasks, augmenting human capabilities, and enabling new opportunity in various industries. And it should be accessible and inclusive AI. And in terms of sustainability and development, it should optimize the energy consumption, enable the smart resource management, and support eco-friendly practices in various sectors. And it should continuously improve and be responsible for the development. And it should not replace human, but rather work collaboratively with them. And it must promote a harmonious coexistence between human and AI technologies. And coming to the conclusion, the human-centered AI prioritizes user empowerment and ethical guidelines, which ensure the AI system enhance the user experiences. And it involves personalized experiences, explainable AI, and grants user the control over AI technologies. And effective human AI collaboration will promote the shared decision-making, user control, and it will leverage complementary strengths for better outcomes. And the collaboration will bring together diverse expertise, broadening insights, and addressing complex challenges in AI development. And by centering on user needs, adhering to ethical standards, and fostering collaboration, AI systems can create a future where technology benefits the humanity, aligns with human aspirations, and promotes societal well-being. And these ethical considerations are crucial for ensuring that the AI system respects the human rights and avoid the biases. And these are some of the references which we have taken in this work, and we have proposed the ethical guidelines. And further, thanks for listening to the presentation, and your questions are most welcome.
Okay, thank you. Dear participant, do you have any question to this paper? Okay, no question. You can continue your second presentation. Dear Usmani.
Yeah, new presentation.
Yes.
Yes, sir. Sure. Sir. The new topic of my presentation is secure integration of IoT-enabled sensors and technologies. That is the engineering.
You can share your. Are there any presentation for this
just a
study?
minute. Yeah, yes, sir. Sure. Can you see it now?
Yes. But this.
The topic of my presentation is secure integration of IoT-enabled sensors.
This is first presentation.
Yeah, just a minute. But this was this one.
Okay.
This is second one. Yes.
Oh.
Just. Can you see now?
Okay.
Yeah, the topic of my next paper presentation is secure integration of IoT-enabled sensors and technologies. Engineering's application for humanitarian impact, and the contents are coming to the. We'll first go through the brief introduction, then we'll ensure the robust security measures, and then the engineering applications in humanitarian context. Then we found the challenges and opportunities in these area, and then we discuss a brief case study of successful implementations, and then we propose the ethical considerations which should be taken in this IoT engineering, and then we'll conclude. Coming to the introduction. The Internet of Things revolutionize the technology interaction, enabling the seamless connectivity, and it plays a crucial role in addressing humanitarian challenges. And the widespread adoption of IoT technologies raises concern about network security. And this work explores the secure integration of IoT-enabled sensors and technologies for engineering applications. Now, coming to ensuring the robust security measures, the importance of security in IoT. That is with the widespread adoption of IoT technologies, ensuring a robust security measure is crucial to protect the sensitive data and prevent the unauthorized access, and implementing strong authentication mechanisms such as password biometrics ensure that only authorized users or device can access the IoT network, and data encryption plays a vital role in securing the IoT communication, and IoT systems should establish and utilize secure communication protocols to establish the encrypted connections and safeguard the data transmission. And it can some factors such as access control and permissions, secure data storage, intrusion detection and prevention, physical security, and security audits and monitoring measures need to be taken in order to ensure that the system is robust and is free from several types of malicious attacks, and the attackers cannot easily penetrate into the network. And coming to the engineering applications in humanitarian context, in terms of it plays a crucial role in disaster management, healthcare monitoring, environmental monitoring, infrastructure development, agriculture, and food security. Where, for example, in the disaster management, it enables early warning systems and real-time monitoring of natural disasters, and it can provide remote care, monitor patients' health conditions, and it can inform decision-making, facilitate timely interventions, and it can efficiently build resource management systems, and it can build us up a suitable, sustainable infrastructure monitoring for improving urban planning and development, and it can optimize the irrigation and crop management systems. Now, coming to the challenges and opportunities, we propose that in terms of resource-constrained environments, deploying the IoT solutions in humanitarian context often involves resource-constrained environments where limited infrastructure, power supply, and connectivity poses challenges to implementation, and it comprises diverse devices and technologies leading to interoperability challenges and ensuring a seamless integration and communication between different IoT devices and platforms is crucial for successful implementation. And the vast amount of data generated by IoT devices present challenges in terms of data storage, processing, and analysis. And the security and privacy concern is that it raises concern about the security and privacy and safeguarding sensitive data, ensuring the secure communication and protecting against the unauthorized access. And further challenges and opportunities like connectivity infrastructure, stakeholder engagement and collaboration, power management and energy efficiency, regulatory and ethical considerations, opportunities for innovation and impact, where the IoT presents significant opportunities for innovation and impact in humanitarian context, And these technologies can revolutionize how we address the humanitarian challenges, enhancing the efficiency and enable the data-driven decision making. And these are some of the case studies of successful implementations where they have been used in disaster management, healthcare monitoring, environmental monitoring, agriculture and food security, smart city solutions. So they have resulted in reduced energy consumption, improved traffic flow, and more efficient waste collection. They have also improved access to healthcare services in remote or underserved areas, enabling timely intervention and reducing the healthcare disparities. And coming to the ethical considerations which we propose in IoT engineering, in terms of data privacy, that protecting an individual's privacy and personal data is paramount in IoT engineering, and obtaining informed consent from individuals whose data is being collected is crucial. And transparency in explaining the purpose of data collection, its usage, and providing individual control over the data promotes the trust and expert the autonomy. And IoT engineer must adhere to responsible data usage practices, and clarifying data ownership and ensuring individuals have control over data is important. And ensuring fairness in IoT system is critical, and engineers must be aware of and address biases that may arise in data collection, algorithmic decision making, or system design to avoid perpetuating discriminatory practices. And there are some ethical considerations in accountability and transparency, security and resilience, user empowerment, impact assessment, and ethical standard and compliance, where adherence to ethical standards, evaluating the potential social, economic, and environmental impact of IoT solutions, and prioritizing the user empowerment, and ensuring the security and resilience of IoT systems, and establishing mechanism for the accountability and transparency in IoT systems is quite important. And coming to the conclusions, in terms of humanitarian impact, these technologies hold an immense potential to address the humanitarian challenges, and ensuring the implementation of robust security measures is crucial to protect the sensitive data, maintain system integrity, and build trust. And the IoT engineering find diverse applications in humanitarian contexts such as disaster management, healthcare monitoring, and it plays a vital role in IoT engineering. And addressing the security concern, adhering to ethical standards, and leveraging the potential of IoT, we can engineer solutions that improve the well-being and quality of life for communications in need. And these are some of the references from which we have taken from our work. And thanks for listening to the presentation. Your questions are most welcome.
Thank you for your presentation. Dear participants, do you have any question last study? About last study?
Yeah, last study, yes, sir.
Okay.
Just a minute.
No question. Thank you again. I wish you success in your career, dear Usman Usmani.
Yes, sir. Thanks, sir. Thanks.
Dear participants, thank you for your attending. I wish all participants continued success. The last session of the day is over. I would like to end this session. Have a good day and good luck.
Yes, sir.
Hope to see you at tomorrow's sessions.
Thanks, sir.